Welcome to the Hydrological Modeling's course. Hydrological modeling is the process of representing complex of water movement within a specific area using mathematical equations. Simply, it's a way to understand how water moves through various components of hydrological system, including rainfall runoff, infiltration, evaporation, and groundwater flow. Hydrological models can be applied to small areas such as a tiny stream to a massive river basin. They allow us to predict future water scenarios and the different climate and land use conditions, which help us to prepare for floods with better forecasting and mitigation strategies. These models also help us to allocate water resource for agriculture, industry, and domestic use. Biological models have different types. Lumped models, also known as single cell model, represent an entire watershed as a single unit. In these models, the entire area is considered a single system, and the input, such as precipitation, and outputs, such as stream flow, are aggregated for the entire area. They are commonly used for quick assessments and preliminary studies. Semi-distributed models. These modes divided the watershed or catchment into multiple spatial units or subcatchments, each represented by a lumped model. These models retain some level of spatial variability by considering different characteristics such as land cover, soil, and terrain. Distributed model. They represent watershed as a grid of smaller spatial units such as grid cells or hydrological response unit, HRUs. These models consider spatial variability in land surface characteristic topography and hydrological processes within each grid cell. They are commonly used for detailed studies. Empirical models, based on observed data and statistical relationships. These models are useful for quick assessments and simple predictions. Conceptual models, simplified representations of hydrological cycle incorporating conceptual reservoirs and flow pathways. These are suitable for watershed scale simulation. Physically based models, based on fundamental principle of fluid mechanics. They are used for detailed studies of specific processes such as groundwater flow or channel hydraulics.